Now let us understand the rules for the nomenclature of the coordinate compounds. And after going through this lecture, you can solve your back exercise questions 5, 6 and 7. So please note it down as your homework assignment, right? So here is the general picture. Whenever you have to name any coordinate compound, or in general any compound, the basic rule which is given by the IUPAC is that first you have to write down the cationic name and then the anionic name. For example, you have NaCl, right, and you are always writing as sodium chloride and not as chloride sodium. So always write the cation first and then anion. And even in formulas, it is the rule that you have to follow is that you have to write the cationic part first, then the anionic part, right? And the second rule is that in case of ionic compound, for example, you have MgCl2, AlCl3, CCl4, and let me just tell you the names, and the names are magnesium chloride, aluminum chloride, and this is not carbon chloride, this is carbon tetrachloride. Now the question is that we have not said that it is aluminum trichloride, it is magnesium dichloride. Why? Because when you have ionic compounds and you know the structure of the cation, you know the cation, it is cation, this one is also cation. So because it is di positive, this is tri positive, and we know that chloride is singly negative ion. So when I say that magnesium chloride, then it is very clear that magnesium has double charge, and that is why it must have double chloride ion. Similarly for aluminum. But when you do not have any charge, then you cannot say whether it is 3 or 4. So you have to specify in such a situations, right? So I mean to say that whenever you have to specify the cationic or anionic part, then you should not mention di or tri. This should be di, tri should be mentioned only if the situation is covalent, right? So let us go, and here is the rule 1. The rule 1 is there is no rule for ionization sphere. Now I think everyone remembers what is ionization sphere. Ionization sphere is that part which is outside this bracket, either on this side or on this side. So you should remember that there is no rule for the ionization sphere. And the second rule is that all the rules are for this black bracket, which is called the coordination sphere, right? So rule 1 means ionization sphere has no rules, and rule 2, coordination sphere has all rules. Alright, now let us learn the rules going through the examples. Okay, in this example, first of all, you are going to locate the bracket, black bracket, and that bracket is very simple, I mean very clear cut, right? Whenever you have to write the name of the coordinate compounds, right, first you have to write the cationic part followed by anionic part, right? So the rule for cationic part, or the rule for coordination sphere, since the cationic part is the coordination sphere, so the rules for coordination sphere is very simple, and the rule is that first you have to write the ligands, right, and prefixes with ligand, how many ligands, right, and then after ligands, and ligand should be in alphabetical order, right, alphabetically order, you have to write down the metal ion, right, along with its Roman oxidation number, right, followed by the anion or whatever part it is, right. So very simple, we have to write the ligands first, and all the ligand must be written in alphabetical orders. Then at the last we will have metal ion with its oxidation number in Roman numerals. Alright. Now let us go and calculate the oxidation number of this central metal ion, which is very simple. As in our previous lecture, we have learned the ligands, and we know that water and ammonia, they are neutral ligands, and this is a negatively charged anion. Now since there are three chlorides, so that means this part is triply negative, right? So that means this part must be triply positive, right? Now very clear, this part is triply negative, so obviously this part is triply positive, just like this one. This is triply negative, so aluminum will be triply positive, right? Now in this positive region, water and ammonia, they have no charge. Alright, so I think everyone can understand only chromium is here to have +3, right? Now how to write down? Now there is compound which is called the amine, which is called A, and water is known as aqua or aquo. Now the first rule is a sub rule. We have to follow the alphabetical orders. This starts with A, this also starts with A, right? Then we should go for next letter A, Q, A, M. So M comes first, then Q, so this will be preferably written first. And now since there are three ammonia, so we will write it as tri T, the first letter should be capital, triamine, right? And we have said that the name should be pronunciated as amamine, so double M, triamine, complete. And then here is aqua, so again start TRI, tri, aqua. Notice that I haven't left any gap between the letters, and they are just a single word, triamine, triaqua, or you can write down aquo, as water has two names. And then comes the chromium, so simply the name is chromium, right? And then in bracket you have to write the oxidation number in Roman numerals like this, right? And now you have to write down the ionization sphere, so you just simply write down chloride. Do not join this. Why? Because the ionization sphere is not joined to the coordination sphere in aqueous medium, so they are separated. This is the part of separation, so you must put a gap. And second condition is that since this part is ionic part, so we must not mention the trichloride, just like we have done in aluminum chloride. We have not mentioned it aluminum trichloride. So you must not put tri before the chloride. And also notice that I have not written the name as chlorido, right? So this does not have any coordinate bond, and therefore I have written it as simply ionic, right? So it's chloride. Alright, so let us now have next example. Now it's a very good example which can tell you the meaning of first rule, that means no rule for ionization sphere. And the rule first says that outside this bracket, whatever it is, di or tri, you have not to mention, right? Because that becomes ionic part. Now since it is sulfate, first of all we are going to calculate the oxidation number of the central metal ion, which is cobalt in this case. Now sulfate has 2 negative charge and there are 3 sulfate, that means it is completely has 6 negative charge, and therefore this complete part must have 6 positive charge, right? And this part is basically twice, here it is written 2, so it is twice, that means this part must have +6 on the 2 pieces. So on one piece it will be only +3, so cobalt has +3 oxidation number. Alright, and this ligand which is known as ethylene diamine, right? Ethylene diamine, and you can see that it is 3 times. So we are going to write as ethylene diamine, but what about 3? We have to write the prefix, right? And in this case the prefix will be little bit different. You are not going to write the tri, you are going to write tris. Alright, tris. And then in bracket you have to write down ethane 1 2 diamine, and then bracket close. Now whenever we are going to use this tris, under what condition we can use this tris? Tris will be used when the ligand's name already contains the prefix di, tri, tetra, right? So this is tris, and you can write down here ethylene diamine, but since we are writing the IUPAC name, so we have also written this as ethylene 1 2, right? First carbon contains amine, second carbon contains amine, so we have written ethane 1 2 diamine. Write down. So it's very simple, and then we have to write cobalt, right? Cobalt, no capital letter except the first one, cobalt, and then within bracket we have to write 3, which is the oxidation number, and then with a gap you have to write the sulfate. Alright, now keep in mind I have not written as di of this because these two exist outside the bracket, right? So it is very clear, you can go reversible with this equation. Now first let us learn something special about the wrong nomenclature. Suppose I write it as triethylene diamine, then using this tri makes the confusion that there are 3 ethylene group, right? There are 3 ethylene group and there are diamine group, right? So to avoid this confusion we will never use tri, tetra, di when the ligand already contains such category of prefixes. So we have a different category of prefix, right? So if the ligand's name already contains di, tri, tetra, penta, hexa, etc., then we will name the ligands if present multiple times as tris for tri, bis for di, if it is 2 times it is 3 times, then tris, and for 4 times it is tetrakis, and 5 times it is pentakis, for 6 times it is hexakis, right? Keep in mind that this kis word contains only single s, not double. Alright, and let us go reversibly. If we have only the name and we have to write down the compound, then how we can proceed backward, because in NCERT, in CBSE you are being asked the questions both ways, right? So this very simple concept is that first of all you have to write down this compound, and I will write in short En, and since it is tris, so I will triple it, and I know that it is neutral, so here is the cobalt, and cobalt has +3, it is mentioned, and then you have sulfate SO4, and I know that it is 2 negative. Now how to balance it? Definitely you will be writing in this way, here is 3 and here is 2. So these 2 and these 3 can be calculated from the common sense. If anybody possesses that, then they can understand y2, y3, right? Nonsense, they cannot understand any rule of the chemistry. If anything is common, then that is never rule, right? Because we expect that we can calculate the charges, right? So do not expect everything that we are going to mention, trisulfate, trichloride, die of all this big stuff, right? So in short, you have to apply your brain, right? So I am teaching the rules. Now, what rules we have understood from these examples? First rule, everything knows that ligand must be written in alphabetical order. After that, we have to write the metals with its oxidation state in Roman numeral. The second rule is that if the name of ligand already contains the prefix di, tri, tetra and etc., then if such ligand is repeated multiple times, then you have not to repeat the letter tri, tetra, di. Instead of that, you are going to repeat the multiple times with using these prefixes bis, tris, tetra, kis, etc. Alright. Okay. Now in these two examples, one thing was very common, and the thing is that the ionization sphere was anionic part and the coordination sphere was the cationic part. Now here is the example in which coordination sphere is anionic and the ionization sphere is cationic. Again, rule 1, no rules for ionization sphere. So if we have potassium and you see that there is 2 potassium, do not write it 2 potassium, just write on potassium with P capital, and mind it that there must be some gap because you are just switching between the ionization and coordination sphere. So this is potassium, and then you have to write down the coordination sphere. So all rules for coordination. First look at the ligand. It is OH negative ion, right? So OH negative ion is known as hydroxo. So I am going to write as tetra, T small, tetra with gap, tetra hydroxo. Then here is zinc. Now this is written as zinc 8, right? Zinc 8. Notice on the word ATE 8, zinc 8, and the oxidation number of zinc is always 2, we all know it. So no need to calculate that. Now when the coordination part is from the anionic, right? Whenever it is from anionic part, always indicate that with this 8 word. So this is zinc 8, right? Let us have one more example. Okay. Now here is 3 potassium, but I am going to write it potassium just one time, potassium with a gap, and then we have to start with this. Alright, so first of all identify the ligand. This is oxalate, right? And we can name it oxalato, and there are 3 oxalic acid oxalates, so we will write tri-oxalato, and then comes the aluminium, right? And I know that aluminium has oxidation number of 3 always, so I will write here 3. Okay, here is the mistake that we have done, right? So let us correct it. It should not be aluminium, it should be aluminate. So aluminate, right? So the same rule, aluminate, then in brackets you have to write the oxidation number. Alright, so now let us have one more example. Now in this example you can understand that there is ethylene diamine. This big compound is written in its short notation, right? So the name is ethylene diamine, and we know that it is multiple times, right? And since the name already contains the prefix di, so we will not write it diethylene diamine like this case, so we will use bis. Alright. Now the name is starting with E, and here is the name starting with C. This is not chloride, it is chlorido. So first we are going to write the chlorido, right? And for this I am writing here di, right? So dichlorido, and then bis, and then in bracket you have to write ethane 1,2-diamine, brackets close, then cobalt. Do not write cobaltate because this part is cationic part, so cobalt with bracket. In bracket I am going to write the oxidation number. Alright. So let us calculate the oxidation number. It's very simple to calculate. Since ethylene diamine has no charge, so it is 0. Chloride has -1 charge and here are 2 chlorides, so here is -2. So the question is, what should be the oxidation number of cobalt so that I get the result as +1, which is shown here. So I think everyone understand that there must be +3. So I will write here 3. Right? So that means this was the certain rule. I think you have grasped the rules. Now let us move further. Now here is the compound. The central metal is a platinum, and here you have amine, means amine, then you have chlorido, and this is a methylamine, so it goes with M. So first we are going to write the A, then C, then M, then platinum, right? And let us calculate the oxidation number of platinum also. We have this as a neutral ligand, -1 charge, so platinum must be +2, right? So I think it's very easy to understand. Let us write down the name. We will write diamine without any gap, then chlorido, okay, chlorido without any gap, methyl amine, single M, then platinum 2. Now after gap you write down chloride. Alright. Now let us have one test for you. Here is the test. So you must write down this after pausing this video, right? Okay, so let us write down this name. The name will be potassium, then after gap tetrachlorido, and then this should be named as palladate, right? Not palladium, it should be palladate because it is from positive part, palladate. And the oxidation number of that is 2, right? Because potassium has double positive charge, chloride has 4 negative charge, so palladium must have double positive charge, right? Next, this short symbol DMG stands for dimethyl-glyoxymato, right? And already it contains the letter D, means di, and here it is 2, so we are going to write the bis, right? So the name is bis, and then in bracket you write down dimethyl-glyoxymato, bracket close, and then nickel. Now the dimethyl-glyoxymate, right? This contains -1 charge, so there are 2 pieces, that means nickel must be in 2 oxidation state. Alright, let us go for next. Now here this one is the best example, right? Here are 2 coordination sphere, right? And every can understand that the meaning of this bracket is that the inner part are not going to ionize. So inner parts are not going to ionize. That means that these pieces are going to split from this part, right? So how to write the name? It is very simple, and first we are going to write with this part because this is the cationic part, and here is 2 amine, so I will write here with capital D, diamine, right? And then Ag stands for silver, right? And silver has always oxidation number of 1. Keep in mind, silver shows oxidation number of 1 in almost every compound, although it also shows +2, but we will be going with +1. Now since this is +1 and this has 0 charge, so that means this part is +1, so this part must be -1 in order to balance the charge. Now here 2 cyano groups and again silver, but this time it becomes anionic part, and we will name the metal of the anionic part with the ending 8. So first we have to put the gap and then again start with dicyano, and then do not write silverate, write argentate, and in brackets write the oxidation state. So I think everyone can understand why I am going to put the gap, right? The gap indicates that from this part they are going to split apart. Alright, next is your test. Now write the name of this compound, and after that we will check it. So pause the video and write the name first. So here is the answer: potassium trioxalato, then iridate, it's from iridium we get iridate, in bracket you are going to write 3. Alright, next example is again including the 2 coordination sphere, and so here are 2 ligands A, C and C. First let us calculate the oxidation number. Now here no trick can work, right? No trick will work. You cannot apply the method of X, right? But here we can apply the concept of D block of elements, oxidation states. Now I am going to give you the shortcut. The shortcut is that when you see that platinum has coordination number of 4, then the oxidation number is always +2. And when platinum has coordination number of 6, 4 and 2, 6, then the oxidation number is +4. Platinum can never show any other oxidation state other than 2 and 4. This should be kept in mind. And the neighbor of the platinum, nickel, palladium, platinum, they behave in the same way, right? And you can notice that here is palladium, the oxidation state is 2, and for nickel you can have either 0, 2 or 4, right? So what I have suggested you, what I have hint to you, the hint is that whenever the coordination number is equal to 4, then oxidation number is +2. If coordination number is 6, then oxidation number is +4. This is for these 3 people, right? And for chromium and cobalt, if the coordination number you find to be 6, then oxidation number will be +3, right? So these are just the hint for the getting the oxidation number without undergoing the calculations, right? So now let us understand. Since there is 2 chlorine, that means there is 2 negative charge and there is +4, so overall the result will be +2 on this sphere. And since there is +2 and there is -4, so overall charge will be -2 for this sphere. and we can understand +2 and -2 makes neutral. So name, from amine we write capital T, tetra, right? Now keep in mind that whenever I am going to write the tetra, then there is A, and in amine again there is A, so both A must be repeated, both the A's must be repeated. Tetra amamine dichlorido, then platinum in brackets you will write in Roman 4, right? Then gap, after that we will write tetra chlorido, then platinate with its oxidation number 2, right? Next, again we have platinum with 4 pyridine, so we will write it tetra pyridine. Now the oxidation number of platinum must be +2 because the coordination number is 4, so oxidation must be +2, and one can easily justify since pyridine is neutral, so this sphere will be +2, and since here is -4, so overall charge will be -2. So the name is tetrapyridine platinum 2 with a gap tetrachlorido platinate 2. Alright, now next, it's very simple and we will apply this shortcut. Now since here is 6 coordination number, 5 amines, 1 isothiocyanate, so chromium will be +3 and zinc everyone knows that +2. Okay, so again from P pentaamamine, then isothiocyaneto chromium 3, after gap tetra chlorido zincate 2. Alright, next, now it's a little bit larger name. So here is PPH3, PPH3 means triphenylphosphine, and here is carbonyl. Now the triphenylphosphine starts the name with T and this from C, so we will write first carbonyl. So go with penta carbonyl, then triphenyl phosphine, then chromium, and on chromium the charge is 0 because no one out of these 2 ligand is charged 1, right? So this is the complete name. Next is this one, and again we have 12 and the prefix for 12 is dudeca and carbonyl, dudeca carbonyl, and here is 3 manganese, so we will write trimanganese 0. Even if metals are repeated you have to write it tri, ligands are repeated you have to write them, but not outside the coordination sphere, no rules for outside. And the last example, which is your test, you can go with this, right? So this question was asked in IIT, right? So pause the video and write down. Now the answer is, let us start with the hint. If you write mercury Hg, right, then Hg should be doubly positive charged. and to write mercury as +1 you have to write it in diameric form. This is mercury +1, this is mercury +2, right? Since I have only one Hg symbolically, so this mercury must be +2, and here are thiocyanate 4, so it should be -4, so cobalt must be +2. Alright, now let us write down very clearly. I cannot write it mercury, right? Just like potassium. I have to write it mercuric, and then gap, then tetra, thio, cyanato, cobaltate with 2 its oxidation number. Alright. Let us now name some bridge complexes. Okay, first of all we should know what are bridge complexes. So here is this brief explanation. If you get two metal and those metals are bridged by some ligand like this one, so these are called the bridge compounds, right? So these are called the bridge compounds, and the name of the bridge compound is very simple, right? I will start from the lowest one, right? So in this case, first of all, the rule says that we must know the oxidation number, and if we do not know, first go and calculate it, right? So here is the hint. Since cobalt is bonded to this group and to ethylene diamine, right? One ethylene diamine makes 2 bonds, so 2 ethylene diamine makes 4 bonds. So 4 bonds, 2 bonds, 6 bonds, 6 coordination number plus 3 oxidation number from the hint that we have studied. Coordination number 6, oxidation number 3. Alright. So the oxidation number is 3 and the oxidation number is 3 for this one also. Now, how to write down? Again, cationic part first, then the anionic part. So here is ethylene diamine, and I will write it bis, and then ethane, 1,2-diamine, then comes the cobalt, right? You write here cobalt with its oxidation number as 3, right? And now this symbol mu, it signifies that there is a bridge. It is used to indicate the bridge. Now bridge compound contains 2 ligands, this one and this one. This one is amido and this one is hydroxo. So first I will write the amido. So I will write mu amido. Again for next I will write mu hydroxo, right? And now we have crossed the bridge to write the name of this. Again go with bis in brackets, ethane, 1,2-diamine, bracket close, then cobalt, brackets with 3 oxidation number, then after gap you have to write sulfate. So this is a single word, okay? Let us highlight the single word. This is a single word up to this, right? So whenever you have to write this compound in your exam, keep in mind of space always. Do not break the word, right? Now let us go and write the next one, right? This was more simple. So here is again cobalt, right? And you can understand there is 4 coordination and 2 here, that means 6, so it is +3. 6 means it is +3. right? So let us go and write the name. The name will be tetra amine. Then this is called imido, starting with I, imido and nitro N. So I comes first. So mu imido, mu nitro, again tetra. Oh, wait, we have to write down the cobalt first. So after nitro, no, we have to write this cobalt on this part, right? So let us erase this first. So tetraamine, without any gap, write down cobalt 3, then bridge mu, imido, again one more bridge, nitro, and then again start with tetra amine, cobalt 3, and lastly iron. Why? Because it is iron. Now this compound is very big compound, right? So first we should know the ligands. This is triphenylphosphine and chloride. And since palladium has again 4 bonds, so I know it is +2, right? Now let us write the name. This is T for triphenylphosphine. Okay, now again we have done the wrong, right? So let us first correct it. Now since this should be alphabetically first and this should be after this, so we have to write first chlorido triphenyl phosphine palladium 2, and then you have bridge. Now after writing this symbol, both the bridges, since they are same, we can write here dichlorido, again chlorido. See the dichlorido is this red one, this is dichlorido, and then this one again chlorido, then triphenyl phosphine palladium 2, right? So let us highlight the single word. Here is the single word, you can understand this is the single word. Alright. So this completes the nomenclature.